Hello, my dear student. It's Dr. Cliff. You're welcome. Today we're going to be talking about the disproportionation versus coproportionation reaction. Okay, the differences between disproportionation reaction and coproportionation reaction. Now you must be knowing that disproportionation and coproportionation reaction, they are both examples of redox reaction. Okay, they are both redox reaction. Okay, let's get down to to the differences between disproportionation and coproportionation reaction. Now follow me. Now disproportionation reaction is also called dismutation reaction. Okay, now dismutation is a term that is applied, okay, that refers to reactions in biological system, while disproportionation is a term that refers to reactions in chemical system. All right, now disproportionation is a type of redox reaction in which one species is simultaneously oxidized and reduced. What does that imply? What does that mean? Now, if you come to coproportionation is a type of redox reaction in which two reactants containing same element in different oxidation states will form a product in which elements reach the same oxidation state. So that is coproportionation reaction. So don't worry, before the end of this video, you're going to see the classical differences between disproportionation and coproportionation. So don't go away. Let's get started. Now, disproportionation. To understand the differences, to understand what disproportionation really, is all about, we need to put forward a chemical equation. All right. So here we have hydrogen peroxide. Okay. So this is an equation we have. So here, oxygen is, the oxidation state of oxygen is -1. Don't forget oxygen is -1 in peroxide, and in oxide, oxygen is what? Oxygen is -2. Okay, but in oxide, oxygen is -2. In peroxide, oxygen is this hydrogen peroxide. So in peroxide, oxygen is -1. So in superoxide, oxygen is what? -half. So here, oxygen is what? 0. Why? Element in the free state has oxidation number of what? Of 0. Okay, now when we spot them out, so from here to here, and from here to here, and okay, from here to here. All right, so what do you see? You see that from here to here, from -1 to -2 is what? From -1 to -2, we're going to call that from -1 to 0. Okay, from -1 all the way to 0 is what? Increase. So an increase in oxidation number is what? Oxidation. All right, oxidation. So from -1 to -2 is what? A decrease. Okay, so and that is going to be what? Reduction. Okay, a decrease in oxidation number is reduction. So that's one of the definitions of reduction. All right, so now you can see that one species, a single species, simultaneously undergoes reduction and oxidation. Okay, so this is a classical example of disproportionation reaction. So let me give you another example. Okay, here we have NO2 plus H2O giving us HNO3 plus HNO2. Okay, so you can see that when this is oxide of non-metal, this is nitrogen 4 oxide. Okay, nitrogen 4 oxide is regarded as acid anhydride. It's regarded as, a mixed acid anhydride or double acid anhydride. This is because when it dissolves in water, it gives rise to what? Two different acids. Now, normally when acid anhydride dissolves in water, okay, when acid anhydride dissolves in water, they usually give rise to what? Acid. Okay, so when carbon 4 oxide dissolves in water, it gives rise to carbonic acid. So when SO3 dissolve in water. Sulfur 6 oxide dissolves in water. It gives rise to what? H2SO4. Okay, sulfuric acid. Now you can see that oxide of non-metals, which dissolve in water to produce acid, we call them what? Acid anhydride. So these guys are what? Acid anhydride. Okay, so NO2 is an acid anhydride. It's a special type of acid anhydride. This is because when it dissolves in water, it gives rise to the formation of what? Two acids. Okay, two acids. So that's the reason why we call it, chemists refer to it as what? Double acid anhydride. Okay, or mixed acid anhydride. Mixed. Okay, you can see mixed acid anhydride or double acid anhydride. Okay, let's get back to business. So this is nitrogen here, the oxidation state of nitrogen. Let's assign oxidation state to the various components. Nitrogen here is what? +4. Nitrogen here is +5. Nitrogen here is +3. So you can see that from here to here, and from here to here. So what did you see? So you see that from +4 all the way to +3, that's what? A decrease in oxidation number. And a decrease in oxidation number, we call it what? Reduction. Okay, this is reduction. From +4 to +5, come on, it's an increase in oxidation number, and that is what? Oxidation. Okay, good. So one of the definitions of oxidation is what? Increase. An increase in oxidation number. And one of the definitions of reduction is what? A decrease in oxidation what? Number. Okay. Now you can see that a single species simultaneously undergoes oxidation and what? Reduction. So this is an example of disproportionation reaction. Okay, so with these two examples, we are good to go for disproportionation reaction. So now we understand what disproportionation reaction is all about. Now you must be knowing that disproportionation reaction is the opposite of coproportionation what? Reaction. Now let's get down with this. So for disproportionation reaction, now let's say we have hydrogen sulfide plus hydrogen sulfide reacts with what? Sulfur 4 oxide to give us, that gives us what? 3 sulfur. So I'm just going to balance it here. So 3 sulfur plus what? Water. Elemental sulfur. So here we're going to have, here sulfur is what? Sulfur is what? -2. Here sulfur is +4. This is sulfur 4 oxide. So here element in the free state is 0. Oxidation number of sulfur here is 0. Element in the free state. So let's go back to the definition of coproportionation reaction. We say that it is a type of redox reaction in which two reactants containing same element in different oxidation states. Two reactants containing same element in different oxidation states. Now, what's the same element here? These are the two reactants containing same element. The same element are sulfur, right? You know, containing same element in different oxidation states. They will form a product. This is a product in which elements reach the same oxidation state. You can see that both of them, they go to reach the same oxidation state of 0, okay, in the product here. Isn't it? You get the explanation now, right? So -2 goes to 0, +4 goes to what? To 0, isn't it? So this is a classical, a perfect example of what? Coproportionation reaction. Okay, in coproportionation, this is just the example. Now let me give you another. So here we have iron 3 chloride plus iron 3 chloride. We react with powdered iron to give us iron 2 chloride. Now let's take out iron. So iron here is +3, iron here is 0, element in the free state. Iron here is this iron 2 +2. So from here to here, and from here to here. Okay, so what do you see? From +3 to +2, that's what? A decrease. This is reduction. So from 0 to +2, that's an increase. That's oxidation. So you can see that, you can see that they both go to the same oxidation state in the product. Okay, so this, you can see the differences between disproportionation and coproportionation reaction. Don't forget that coproportionation reaction is also called proportionation. Proportionation. Okay, that's another name you can call it. All right, so we're done with that. Now, this is the difference between them based on definition. Okay, you can see the definition now, and we're giving example to buttress the points. Now, secondly, you must know that in disproportionation reaction result in two different oxidation states of same element. Okay, it results in two different oxidation states of same element, isn't it? So you can see different oxidation state of same element, oxygen. You can see disproportionation reaction results in two different oxidation state of same element. What's the same element here? Oxygen. The same thing here, nitrogen of same element, nitrogen, right? Good. But for the coproportionation reaction, it results in a product with an intermediate oxidation state. Now, what do we mean by intermediate oxidation state? If you take a look at, now the product is an intermediate intermediate oxidation state. What do I mean by that? If you come here, sulfur here is what? -2. Sulfur here is +4. And sulfur here is 0. So between this is for the product. Now the product has oxidation state of 0. Now 0 is in between -2 and +4. So in your number line, you're going to start from -2, 0, +4. You can see that 0, which is the oxidation state of the product, is in between -2 and +4. So it's an intermediate oxidation state. Let's also see for this. Now for this, the product has oxidation state of what? +2. Okay, +2. Now the reactant, +3 and 0. Okay, so from 0 here, +3. You see that +2 is an intermediate oxidation state. Okay, so it's an intermediate. It's in between. So that's why we say that coproportionation reaction results in a product with an intermediate oxidation state. So this oxidation state here is in between, it's an intermediate between +3 and 0, and this oxidation state here is intermediate between -2 and +4. All right. So lastly, disproportionation reaction involves a single species. Okay, it typically involves a single species, okay, undergoing self-redox reaction. Look at it. The only species that is involved here, this is the only species that is involved here, right? Here, the only species that is involved here is this one. This one, water is not part of the reaction. It's not involved. Only this is involved. So it involves only a single species, okay? But when we come to coproportionation reaction, it involves two different species with different oxidation state. For example, this and this and this. Two different species, okay, with different oxidation state. So these are the differences you need to know regarding disproportionation and coproportionation reaction. This is the end of the tutorial video. It's Dr. Cliff. Bye for now.